Okay, we continue our lesson today. This one is just for the review, because last week we have seen the absorption and distributive. This one we have seen absorption and distributive. Then for today, we look. Okay, this one is example. Show that P or Q or negate P is a tautology. Tautology, what is tautology? Tautology, all of the value, okay, all of the value must be true. Lah. Okay, and then we have here P or Q or negate P. This one for the negation P, we call it as commutative. Commutative. And then we negate, we call it as a negation, and name of the equivalences, we name it as domination. Domination. This one is the series of equivalences. Okay, is it okay for now? Is it okay, guys? Okay, boleh. Okay, thank you. Okay, again, tautology is proposition is always true regardless of the true value of the proportional variable that contain of it. Okay, that one you must be remind for the tautology. And then we have commutative. Okay, and then domination. Domination is uh, we have here. Okay, is biconditional. Q and F is equivalent to false. This one we call it as domination. Okay, this one is truth table. Shows that P or Q or negate P is a tautology. Okay, we have defined this one last week. 2 power of 0 is equivalent to 1, 2 power of 1 equivalent to 2, and 2 power of 2 equivalent to 4. That's why 1, 2, 3, 4. And then this one, P or Q or negate P is equivalent to true. Okay, this one we call it as implication is tautology. Okay, important of equivalences involving the implication. That implication equivalences that we have the here. We have a conditional statement. We have a contrapositive. Okay, we have a biconditional. One, two, three, four. This one is a biconditional. Okay, here biconditional, and then we have equivalences. P implies Q and Q implies P lah. Okay, this one is not or. Okay, this one N must be N. Okay, this one for conditional statement and contrapositive. You need to contradict. Okay, contradict the statement. Okay, this one is contrapositive. You need to change the position. Okay, you need to inverse. Okay, we have here negate H or C. Okay, here. Okay, and then equivalent to negate P or Q. Lah. Okay, this one contrapositive. You first need to inverse and then converse, and then third step is you need to contrapositive. This one we have I have explained in last week. Last week you have known this one. Okay, we change the position and then you negate. Negate. Okay, this one is contrapositive. Okay, P implies Q is a conditional statement. Negate Q implies negate P is contrapositive because you are inversing the statement. Okay, and then P implies Q equivalent to negate Q implies to negate P lah. Okay, as you can see here is we have 2 power of 0, 2 power of 1. Okay, and then here because we have 2 power of 2 lah, is equivalent to 4. Here 1, 2, 3, and 4 lah. Okay, for the exercise, show that left P implies Q and right P and negate Q are logically equivalent. Okay, how? This one you need to answer in the uh, Padlet. You need to upload to Padlet. Okay, show that this one, 2, and 3. Show that P and Q implies P or Q is equivalent to true. This one is easier to simplify. Okay, the complement. Okay, okay. This one is just for exercise. Okay, for the answer, show that negate P implies Q and P and negate Q are logically equivalent. First, you need to have left to right and right to left. Okay, here P implies Q implication, and then we negate. Okay, we remove the uh, negation. Okay, negate P or Q lah, is equivalent, and then we go for the De Morgan law. Okay, and then we have a double negation. P and negate Q is the final one, and then we go by the right to left. Okay, right to left. P and negate Q. This one is we just inverse De Morgan, and then implication and equivalence. That we have the final one is negate P implies Q lah. Okay, we just remove we just exchange this one left to right exchange lah. Okay, we exchange the position okay, this one you need to know implication, equivalence, De Morgan lah, and then we have a double negation. Okay, and then here first De Morgan, secondly implication, okay, third equivalence, and then fourth is double negation same. Okay, okay, so far do you have any question? Ada soalan ke? Ikhwan okay? Yeah. You need to upload your own notes in the Padlet. Okay. Before 10 p.m. Okay. This why is important because if you have the notes, you can revise later on. Okay. You need to update the last one that you upload. Just update. Just update for next chapter lah. Okay, this one show that P and Q implies P or Q lah, is a tautology lah. Okay, first we go for the left to right lah. Okay, P and Q and P or Q lah. This one implication. Okay, we go by equivalence, De Morgan, commutative, and negation. Okay. Okay, and then we compare. Okay, this one true and false. This one as a negation. We negate. Okay, we negate. That's why we can have the tautology. Okay, same show that P and Q implies P or Q is a tautology. Also the same. Okay. Okay, this one is proven lah. Okay, proven that show that negate P implies Q and P and negate Q are logically equivalent. Okay, this one how you want to prove lah. The step by step is showed here. Okay, we need to have the implication first, implication equivalence, and then secondly De Morgan, and then commutative, commutative, and then we negate, and lastly we disjunction. Okay, true or true is equivalent to true. One plus one equivalent to one. Okay. Okay, we continue to chapter 1.3. This one predicate and quantifier. Okay, we want to quantify the predicate. We want to measure the predicates. Okay, the predicate x is greater than 3. They have three Boolean indicator. First one is true. Secondly is false. Thirdly is unknown. Okay, for example, a predicate is statement that contains the variables. For example, x is greater than 3. Okay, you can just stated that p. Okay, let's say you have a 4 also same. Okay, and then you can uh, uh, infer that 4 is greater than 3 is equivalent to true. Okay, also same. P we have negative 4. Okay, negative 4 is greater than 3 is false. Okay, this one is predicate. Predicate. You need to have the predicate. Predicate that contain the variable. Okay, contain the variable x and y, and then x equivalent to y plus 3 is the statement. Left hand side is the predicate, right hand side is the statement. Okay, and then the predicate you can have also more than one variable, x, y, z, and so on. Okay, and then x plus y is equivalent to z. Z. Okay, this one is a predicate must contain variable. Okay, predicate is become a proposition if the variable content is or are assigned specific value or quantified. Okay, this one uh, predicate that we discussed before this is not uh, is not assigned as a proposition. Okay, when it is proposition, it must contain two lah, one and two lah. Assign specific value, you might assign, and then it can be quantified. It cannot be unknown. Okay. For example, we have p x that contain variable x. X is greater than 3. What are the true value of p4 and p2? Okay. Okay, and then q xy, we have a predicate here, and then we have the okay, we have the predicate, and then we have the statement. Statement x plus y. What are the true value of q 1 and 2 and q 3 and 0, you must assign, and then you must quantify. You must measure. You must calculate. You must calculate the proposition. Okay, this one quantified. You must measure. Okay, quantifier. Two types of quantifier. We have universal quantifier. Okay, like this, and then you have existential quantifier. Okay, some of the internet references refer to the E. E is wrong. Okay, and then you have a universe of discourse, the particular domain of the variable in propositional function. Okay, we have here subset here. Okay, this one is for all. Okay, for some here we have existential quantifier. Okay, and then you have a universe of discourse. This one. Okay, universe of discourse. This one for all of these. We name it as a universe of discourse. Okay, for example, we have Px is true for all the value of x in the universe of discourse. Okay, this one is example for all. Px is true. For example, we have x, we have Px. Okay, for all x. Okay, for every x. Okay, the variable x is bound by the universal quantifier, producing a proposition. Okay, later we see whether is x is free or x is bound. So when x is free, it's not quantified. Hello, yes, Amira, ada soalan ke? Oh, okay, okay. Okay, and then when x is bound, when it is quantified. Okay, this one is the different. Okay, and then the variable x for for all x for every x is bound by the universal quantifier. Okay, and when x is free, it's not quantified. It's not bound. Okay, for the example, for the universe of discourse is the domain. This one is for the domain. All real numbers px x plus 1 are greater than x for all x for every variable of x is true. Okay, all real numbers here less than 2. Okay, for all student in MTK, X has account on tabung haji. What does for all X are X? This one, what does it mean? It means that for all student in MTK has account on tabung haji lah. Okay, this one is direct interpretation for all. Okay, you must remember for all you need to have a domain. Okay, you need to have to quantify. First you need to assign a specific value for the predicate, and then you need to quantify. Okay, this one is two condition you must remember. Okay, for universal quantification, we have px. Okay, is equivalent to px and px2 and so on. If listed, the universe of discourse can be listed as u. Okay, this one is for the domain, and then for all x px, okay, is equivalent to px1, okay, and px2 and so on. Okay, u is for the domain. Positive integers not exceeding the 3, and px x power of 2 is not less than 10. Okay, what is the truth value of for all x px? Okay, this one is p. For example, we have a 3, not exceeding 3. We have p1 and p2 and p3. This one true and true and true. We have 1 plus n is multiplied by 1. Multiplied by 1 is equivalent to 1 lah. Okay, which means this one is true lah. Okay, that one is for all. For all, the other one is existential. Existential mean the domain is for this course. You have a sum. Sum. Okay, sum of universe of this course. Okay, for example, for some x, we have px. There exists, or you can have there is at least one. Okay, it's not all. It's not all. But the variable x is bounded by existential quantifier producing a proposition. Same goes to the universal quantification for all. Okay, same. Okay, this one is bounded. Bounded because you have the quantifier. That's why x is bounded. Bounded. Okay. Okay, for example, we have same for all real numbers p x is greater than 3. What is the truth number? Okay, what is truth value? Okay, x has some account on tabung haji lah. What does it mean? It means that some of the student in MTK 3013 have account in tabung haji lah. Okay, this one, if you have the positive number not exceeding than 4, then we have px, okay, for the variables, okay, and then we have statement x greater than 10. Okay, we have p from 1 and p2 or p3 or p4 lah. Okay, okay, this one is equivalent to uh, for some. Okay, this one is not every of this is truth value. Okay, for some mean that there is some values in variable 1, 2, 3, 4 is false. Okay. Okay, binding the variable, bounded variable. This one I have explained. If a variable is being quantified, for example, we have for the quantification, we have a free variable and the bound or assign of specific value. Okay, for example, we have for all and for some. The scope of quantifier part of logical expression which quantifier is applied. Okay, for example here. Okay, negation. For example here, which one is bounded, which one is not bounded? Okay, which one is bounded, which one is unbounded? Could somebody tell? Not clear. Is it clear? Can I explain it? Okay, for the two different rule in the predicate logic, we have bound occurrences, and the second one is free. Okay, for example, we have like this. Okay, x. Okay, we have x, y, and z plus. Okay, okay, which one is bounded? Which one in here is bounded? Damien, which one is bounded? Here is bounded. Okay, bound because bound occurrences. Because you can see existential x, x is bounded. Okay, that this one for the example one. Okay, for the example two. Okay, example two, we have existential x and negation y. Okay, here y is bounded. Okay, okay, whether an assignment satisfy a formula in a model of none depend only on the values on the variables that occur free in the formula that is not bounded by any quantifier. Okay, that one is free and bounded. Okay, and then we have a negation. Negation of quantifier distribution the negation operator across the quantifier changes a universal to an existential and vice versa. Okay, for example, we negate for all x, px. Okay, and then is equivalent to uh, existing x negate px. Okay, same. Okay, for example here, px, x has taken the course in calculus. Okay, okay, and then you want to quantify, you need to translate. Translate a given sentence. A goal is to produce a logical expression that is simple, that can be easily used in subsequent reasoning. They have a three step here. First one, clearly identify the appropriate quantifier. Okay, either it is existential or for all. And then secondly, introduce the variable and predicates. Okay, and then thirdly, translate using the quantifier, predicates, and logical operator. Three. There are three possibility here. Okay, for example, every student in this class has studied discrete structure. Lah. Okay, assume for the universe of this course, okay, we have all students in MTK. And solution number two, assume uh, you can also write for all people. Okay. Okay, more example. We have CX. X is computing student. MX. X is a multimedia students. It's depending. C. What you interpret. C is computing. M. You name it as a multimedia. S is smart. Okay, smart students. Okay. For the domain of the discourse, all of the student are taking MTK lah, in MTK 3013 lah. Okay. Okay. When you want to have the translation, okay, for this one, everyone is computing student. Okay, you have for all X. Okay, for all X. Okay, is CX. Okay, and then nobody is a multimedia student. Okay, you can have for all X. Okay, is you negate the MX. Negate the MX, or you can have existential X MX. Okay, and you negate. Okay. This one is for nobody. And then you can say all of computing students are smart students. Okay, for all X. Okay, bracket CX implies to SX. S for the smart. Okay, C is computing. Okay, then the last one for some. For some students are smart students. Okay, are smart student. That means you need to combine for the and operation. Okay, and N is the compound statement. CX is a computing and SX is smart. And then you uh, existential X. Okay, this one is the for the example. And then universal quantifier usually takes implication. All computing student are smart student. For example, okay, for all CX implies SX. Okay, this one is correct. This one is incorrect. Because for all is incorrect to have the compound statement. Okay, is incorrect, because in universal quantifier you need the implication. Okay, implication or conjunction. Existential, yes, you need to have conjunction, but for the universal quantifier you need the implication. Okay, conjunction meant for existential. Please remember, this one is incorrect lah, because you cannot state, or you cannot define all of the some of the person, you cannot imply for all. You cannot generalize. This one is incorrect because you need to have an conjunction. This one for existential. Okay, more example. Non-computing students is a multimedia students. You can see if a computing student, then the student is not a multimedia students. Okay, you can have implication here, because this one is for all. There is not actually a computing student who is also multimedia student, because you need to compound, you need to combine. That's why you need this one conjunction. And thirdly, if any multimedia student is a smart student, then he also a computing student. Okay, you can combine also for all x. You have a multimedia student mx. Okay, and also multimedia student is a smart student as x. Okay, all of these are computing students, implies to cx. Okay, do you have any question? Hamdan, okay? Nini, okay? Boleh ke? Boleh. Akil boleh? Akil? Boleh. Bukan semua ayat. It depend on the cases lah. Uh, depend on the cases lah. Contoh for example, if any multimedia student, is a general, multimedia student is general, is a smart student, and he also is a computing student lah. Bila, yeah, kalau ada n then or n lah, then he is a computing student. You need to combine multimedia student and a smart student. Is a smart student. Combine is a conjunction. Dia kena depend on situation. Depend on situation. You need to think logically lah. Okay, for example, if any multimedia student is a smart student. Okay, I give you another example. Okay, another example. What else? Hmm, Okay, they say you want to say that rain. Okay, x. Uh, okay, x or y. Right. Okay. You can have x is a day, y is a rainy day. Okay. X is a day, y is a rainy day, and z is a sunny day. Uh, if you say that if it is raining, then there is no sunny day. Okay, how you want to convert to English? Convert to to either you use the implication or conjunction. Okay, you can say uh, all x is for the day. Okay, you can say y x. Okay, and uh, okay. If it is rainy day, then there is no sunny day. You need to negate negate this one. Okay. Okay, this one is just an example. Later, I give you some of the example. Okay, and then you can also have the nested quantifier. Okay, for example, quantifier that occur within the scope of the other quantifier. For example, we have a p, x, and y is the variable. X plus y is equivalent to 0. Okay, and then you have u, universal quantifier. Okay, in R. Okay, the scope. Okay. Okay, for example, we have for all x, existential y. Okay, and then we have p, x, y for some, for all. Okay, this one is nested lah. Okay, for example here we have two variable combined. Okay, we have for all pair xy, pxy. For every x, there is y such that pxy lah. Okay, for every x, there is y such that pxy. You can say for all x, there exists y pxy lah. Okay, you can have also there is such x such that pxy for all y lah. Okay, do you have any questions so far? Is it okay? Okay, there is a pair of x such that pxy. Okay, there exists x, there exists y, and then you have pxy. Also same here. You can also have x first or y first, or you can have also y first, x later. Okay, it's the same like this. Okay, and then you need to translate the sentences. Okay, this one for all people. If a person is a female and is a parent, then there is a person is someone mother's lah. This one is for u for the all integers. The sum of two positive integers is positive. Okay. Is order of quantifier important? If the quantifiers are on the same type, then orders doesn't matter lah. Okay, if the quantifier are on the different types, then the order is important lah. For example, okay, we have a universe of discourse as a subset, and then Q x y x plus y is equivalent to 0. And then what are the truth value for all y, for some y, for all x? We have x, y, and for all x, for some y, we have x and y. Okay, not for every, only when y is negative x. Okay, that exists. But for every, is true. Okay, this one is the quantifier on the same and the different types. Okay, for every real number x, there is a real number y such as q, xy is true. Example, x plus 1 is 0 is true. Okay, there exists at least one y for that every real number. Every real number is false because not for every, only when y is negative. Y is negative. Okay, this one is the example for this one. If the quantifier are on the same type, and then the order is doesn't matter lah. If the quantifier on the different types, and the order is important lah. Okay, do you have any questions so far? Is it okay?